Hello and welcome to another lesson in PIC microcontrollers, implementation and software development. Today we will be, or rather tonight, we will be looking at stepper motors. I know this is kind of an interesting topic because I've seen lots of stepper motor controllers that have a pretty wide range in price that can be very expensive. Now, of course, a price always comes with functionality. I'm experimenting with a TI chip right now that can do basically all the different, like, half stepping, quarter stepping, micro stepping, and all that stuff. Functionality already built into it. But for those of us that just want to build a simple software solution for it that will work, we're not doing any super robust things with them. I'm going to show you today how to create a very simple software driven stepper controller using a PIC microcontroller. You can use any microcontroller to do this. All you're doing is just basically turning things on and off to energize and de-energize the internal magnets of the stepper. So what we're going to do is we've got our chip here, and I'm actually, before we show this, I'm going to grab a data sheet. We're going to do a very simple stepper. It's just a 0.9 degree stepper motor. It is just a two-phase, nothing real complicated. You can get, those great big ones that have 8 phases or something like that in them, and they're huge and they can do all kinds of sorts of things. But right now we're just going to keep it simple. Oh, and by the way, you can buy these off eBay. eBay's where I've found a lot of steppers, a lot of very good steppers that people may have taken out of CNC machines or printers. Printers is another excellent source of stepper motors. Of course, I guess the next step to a stepper motor is a servo motor. Now, the difference, those of you that don't know the difference between a stepper motor, which is what we're going to be working with, and a servo motor that's used a lot in robotics, is that a servo motor gives you feedback. It actually feeds back its position and tells you where it's at after you've actuated it. Whereas a stepper does not. You send it a pulse, like a pulse width modulated signal, PWM wave, through those transistors, and that's pretty much it. You basically just tell it how many steps it needs to take, and you just hope that it makes it there. Now, most of the time, what I've seen is most people will put their own feedback in, whether it be a counter or of some sort, some type of counting system to give them feedback on how many steps that they told it to step and how many steps it actually moved. So, like I said, and steppers, some steppers tend to be cheaper than servos. Some steppers can get very expensive too, so it depends. Depends on your application of which one you want to go with. But for this tutorial, we're going to do stepper motors, and very simple stepper motors. So we got the two-phase, 12-volt, just a little stepper motor. Nothing real beefy. If you guys need me to, this is another thing. I'm not going to go into what the holding torque and rotor inertia and basically how to use all this, basically how to size a stepper motor. If you guys would like me to go through a tutorial on how to actually size them, just let me know in the comments and stuff, and I'll see what I can do. I might be able to throw together a tutorial on how to actually size stepper motors for different loads and torque specifications. But basically all we got here is you've got your two phases, and these are split phases is what these are. And how we're going to be connecting them is we're going to be tying the two center phases to 12 volts, and then we are going to be actuating this pin 1, 3, 4, and 6, basically pulling those to ground in a certain sequence. And I'll show you the sequence later on in the software portion of part 2 of this video tutorial. I'll show you the software sequencing on how to sequence that, but that's basically what you got going on here. There's the rotor, and here's your coils. So now I'll compare these two to here. Basically, I had to draw a connector. What this connector is this 5 and 6 pulled to 12 volts represents this yellow and this white being pulled to 12 volts. Okay, and then we are going to take and, like I said, we're going to actuate these pins. And I'll show you that sequence in a minute. So we're going to connect them to C0, C1, C2, and C3, as you can see. And that corresponds to 1, 2, 3, and 4, which is these different windings here. 1, 3, 4, and 6. And then again, yellow and white are tied to 12 volts. And then we've got our pull-up resistor, as usual, for mem-clear, our power supply, 12 volt in, 5 volt out. And that's basically it for the hardware. It's actually a very simple hardware implementation, if you take a look at it. So anyway, so that's the way we're going to hook it up. I'll be back in the next video for how to do the sequencing and writing the code. Again, the hardware is very simple. The coding is a little more complicated, so I'll show you that when we get done. Thank you very much.